There's a revolution right now going on in the coal bed methane production in China, and we'll also see the principle behind it. Instead of worrying about the absorption, which limit the production, all gases are freed by fracking. Uh, so here we have the coal bed methane production. So before the revolution, it's the conventional coal bed methane production. Past production model is following the Namur storage model. So here is the Namur storage. The gas is absorbed, and so the pressure increase in the reservoir is very, very small. But you can store a lot of gas. That's good for storage, but not good for production. You have the Namur pressure, which is defined that half the gas is stored, and you have a pressure which is only 20 less bar. And there's also the critical pressure, which is only 6 megabar or 60 bar. And at a barrel's depth of 1.5 kilometer, the static water is 150, so you have to flow back the water and lower your bottom hole pressure more than two-thirds almost, before at the critical pressure, lower than the critical pressure before you see the gas start to produce. And so this is the Namur pressure. Unfortunately, abandonment pressure is not far away. So very soon you'll start the production after you finally pump the water out and start the production. But because the bottom hole pressure is low, the lot of water accumulation, you have to fight with water accumulation in the well borehole all the time. So this is the typical production. You have to wait a long time after flow back. Till the reservoir bottom hole pressure low enough here, and then you have some slow gas flowing finally when the water goes away. But you have to constantly fight it because the gas water rate is not very high, and so before long you reach the abandonment pressure, and which is very close to half of the gas still absorbed. So your recovery can't be very good. It can't be 50%, or actually much less. So that's the recovery, and the production cost is high. That's the old conventional way of coal bed methane production. Now with the hydraulic water fracking, you can convert the absorbed gas through water into free gas if you do it properly with the knowledge of modern day fracking technology, hydraulic fracking for shale gas. And with a porosity less than 10%, you can convert the absorbed gas into free gas. Now you have pressure of 150 bar or even higher, So you basically convert the under pressure absorbed storage into free gas over pressure production now. So it's totally different. You can produce very efficiently and produce a long time before you reach the abandonment pressure. So you can easily have 90% recovery, and the production rate is indeed very high. This is the latest result from the fracked, modern day fracked, hydraulic fracked coal bed methane well, deep methane well, not that deep, 1500, and right after flow back, you see the bottom hole pressure build up to 150, and the production rate is very high. Water rate dropped really low, and the production is very efficient and cost less. So this is validated by the bottom hole pressure, very good, and gas water rate is very high, very productive. And how do you know it's converted to free gas? You need to use isotope. We have the isotope measurement tool right on your website, not website, but it can monitor if you have successful fracking. If you have a successful fracking, you should reach the free gas, bulk free gas, and if you have a poor fracking, you have a lighter gas, and then it gets really heavier. So isotope is the key, not just to monitor the fracking and production, but also to measure initially how much gas is really there in the storage. So we have the tools for you. We have the revolution method for you. Now, revolution, let's start it.